Math 3, Unit 6, Section 7. Today we're talking about graphing radical equations. Specifically, we are going to be talking about graphing square roots. Okay, here is your parent graph for a square root function. You'll notice here that it has your starting point or your key point, and that is at 0, 0. Okay, and so in terms of translating, there's nothing inside with the x right now, so that's really like an x plus 0 where the 0 comes from here. And then there's nothing being added at the end, which is where that 0 comes from there. Okay, also to remember with translating, anytime you have the adding c here at the end of the function, it is shifting up. When you have the minus c at the end, it's shifting down. Remember that if you're adding with x here, so you had like plus some value inside here, it actually would be shifting to the left because we set that equal to 0. And the minus c inside like that, you would be shifting to the right. Anytime you have a negative in front of the function, that will reflect it about the x-axis. So that would be kind of a negative in front of there. And then anytime you have a negative x inside here, it will reflect it about the y-axis. Dilation is when you have a constant value a here at the beginning, and that is either going to shrink or enlarge your function. Okay, so we're going to go ahead and start here. The first thing let's look at here is that let's find our key point or starting point. And so again, here at the beginning, our key point or our starting point was at 0, 0. On this function, when you set that equal to 0, the x value is going to be -3, and then the y value is -1. So let's go ahead and mark that point on our graph. And so we have -3, -1, and we're going to go ahead and mark that. So the next thing I want to talk about is our domain and range. And so your domain, we cannot have a negative under the square root, because if we had a negative under the square root, when we bring it out, it becomes an imaginary number. You can also see how all these functions are going to be curving to the right for any functions that doesn't have reflections. So your domain, this right here, basically tells you where your restriction is. And so for this function, the domain starts at -3, and it's going to be anything bigger than -3. And so it can equal -3. In fact, it does equal -3. So we're going to do a bracket at -3, and it's going to go all the way to positive infinity. The range, same thing. And again, we know it's going to go up and right because there's no reflections or anything in it. So it's going to go up and right. And so the smallest range value is given here by this value as well. And so this range, again, it's going to start at -1, and it will go all the way up to positive infinity. Okay, to find your x-intercept, we know that we can, oops, sorry that this is kind of low. Hopefully you saw that. To find your x-intercept, we plug in 0 for y, and I'm just going to make a note right here. Plug in 0 for y and solve for x. So when you have functions, even though it says f of x, we know that's the same thing as saying y. And so if we plug in 0 for y and solve for x, I would write this as 0 equals the square root of x plus 3 minus 1. So we want to get x by itself. We've been solving functions like this in a previous lesson, and so we're going to add 1 to both sides. This eliminates. I have 1 equals the square root of x plus 3. Anytime we want to get rid of a square root, we need to first get the root by itself, and then we can square both sides. When I do that, I get 1 equals x plus 3. I subtract 3 to both sides, and negative 2 equals x. And so my x-intercept is at negative 2, 0, because we got negative 2 for x when we solved, and we had plugged in 0 for y. So negative 2, 0 is this point right here. And then the next thing we want to find is our y-intercept. So we do the same thing as we did previously, except for we plug in 0 for x and solve for y. And I might go ahead and highlight these directions so they're easy to find and look back at later. All right, so I'm going to plug in 0 for x in this equation and solve for y. So we would write this now as y equals the square root of 0 plus 3 minus 1. Okay, and so 0 plus 3 is the square root of 3 minus 1. So we're going to go ahead and approximate what the square root of 3 is, so we have a better idea on our graph. For now, if you wanted to get out a calculator, you can. And so I'm pressing the second button and the root button to give me the square root function. And I'm taking the square root of 3, which is, we're going to approximate that to be about 1.73. And then we're going to subtract 1 from that. And so 1 minus 1.73 gives me, I did not plug that in right, sorry, 1.73 minus 1, and we can just, actually not even have to use our calculators, is 0.73. And so that ordered pair, we plugged in 0 for x, and then we got 0.73 for y. So on our graph, 0.73 is in between 0 and 1, so we're going to make a point there. And then we just go ahead and draw our curve. Okay, so the next question now. So now we have our graph. This makes sense for our domain. Our domain is from -3 to positive infinity. Our range starts at -1 and it will keep increasing as it goes up and up and up. So we have our range. We found our x-intercept. We found our y-intercept. Now it asks for the open interval where f is increasing. Remember that we read graphs from left to right, and so starting at the left of the graph, you'll notice that it's increasing the whole time. Okay, and so it's increasing. Open interval means we don't have to worry about our brackets. So it's just increasing. It starts at -3 and it goes till infinity. Remember that all of our information comes from our domain unless they're asking about our range. Here it says, where is the open interval where f is negative? So negative is when a value is below the x-axis. And so if you look here, the only time this graph is negative where it's below the x-axis is just that little portion right there. And so that little portion right there is only from -3 to -2. Okay, the last thing that they're asking for on here is the average rate of change. The average rate of change is talking about the slope, okay? And you find your slope or your average rate of change using your formula, m equals y2 minus y1 over x2 minus x1. So in order to find the average rate of change, you need 2 ordered pairs in order to use this formula that we have right here. And so they're asking for the average rate of change from this value of 1 all the way to the value of 6. And so these, if you even see right here, they are giving you x values. And so I have an x value of 1, but I don't know the y value. And I have an x value of 6, but I don't know the y value. And so we need to find those values. How can we find those values? Okay, and so hopefully you're thinking about, if we want to know it's this graph we're trying to figure it out for, we need to use our equation, plugging in x values in order to find the y values. So over here to the side, I'm going to go ahead and start with the 1 ordered pair. And using my equation, I'm going to write, and this is the x and the y equals the square root, and then I'm going to plug in 1 for x, plus 3, and then minus 1. So here we have the square root of 4 minus 1, and the square root of 4 breaks down to 2 and 2, so we have 2 minus 1, which is 1. So this y value, y equals 1 when we plug in 1 for x. So this ordered pair is 1, 1. Okay, now we're going to try to find the value for 6. When x is 6, what is y? Again, we use our same equation. Y equals the square root of 6 plus 3 minus 1. And 6 plus 3 is 9, so square root of 9 minus 1. 9 breaks down to 3 and 3, so pair of 3, so we get 3 minus 1. And y equals 2. Okay, and so now that we have that information, we can find our slope. And again, this goes x and y and x and y. So in order to find the average rate of change, which is our slope, we subtract our y's, and so I'm going to subtract 2 minus 1. And since I started with 2, when I'm subtracting the x's, I also have to subtract or start with 6. So then I have 6 minus 1. 2 minus 1 is 1. 6 minus 1 is 5. And so the average rate of change between 1 and 6 is 1/5. All right, so we're going to go ahead and turn the page and do another example. Okay, so here we have another function. There's a few things that you might notice on this. First of all, normally we always have the x part first and then the number part. And so I might go ahead and rewrite this as g of x equals, and so the negative is with that. So I'm going to write this as negative 1/2 root x, and then I have plus 4. Okay, so with that information there, a couple things is that we have some sort of dilation there because there's a constant value being multiplied. And then there's also, it should be reflecting across the x-axis because of that negative there in front. Okay, and so our key point or our starting point, since there is nothing inside there with the x value is 0, and then the y value is 4. So on our graph, we have 0 and then up 1, 2, 3, 4. I'm going to go ahead and skip domain and range for just a minute because of the reflection and stuff, I want to make sure the domain and range makes sense based on our graph. Okay? But X-Intercept. So for the X-Intercept, and again, when I'm finding these values, I'm going to use this equation now that I rewrote. We plug in 0 for y and solve for x. And so for my X-Intercept, I'm going to plug in 0 here for where the y would be. So 0 equals, and then I have negative 1/2 root x plus 4. Okay, so we have a couple things that we can do. The first thing is that I have a fraction there, and I don't really love fractions. You don't have to solve this the way that I do, but I might go ahead and eliminate the fraction by multiplying the entire equation by 2. And so I go through and I write 2 next to every single term. Okay, and remember, terms are separated by pluses and minuses. So like this negative 1/2 root x, that's all one term. Okay, and so 2 times 0 is 0. Here when I multiply by 2, the 2's cancel out, and I just have negative 1 root x now. And then 2 times 4 makes 8. So without the fractions, it's a little easier for me to work with. And so next I'm going to subtract 8 to both sides. And I have negative 8 equals negative 1 root x. And again, I'm trying to get the root by itself. And so I divide by negative 1 to both sides. That cancels out. 2 negatives make a positive. 8 equals root x. And then the last thing in order to get rid of the root is to square both sides. And so I end up getting 64 equals x. Okay, so that means I would write that as 64, 0. And this graph, it's going to be off the graph. And so I think because it's 64, I'm going to count by tens. And so you just need to kind of label that you're going by tens. So I'm going 10, 20, 30, 40, 50, 60, and then 64 would be somewhere right in there. And you could label that point as 64. So if you see here on this one, since this point is here and this is here, and we know it's reflecting across the x-axis, normally our curves would be going up, but because it's reflecting, it's going to actually be curving down. And since I found where that x-intercept was, it made it a little easier to see how this is curving. Okay? And so if I go back now to my domain and range, my domain is my x values, and the x values are starting at 0. So my domain is 0 to positive infinity because it's still going right. But for my range, my smallest range value, the range is starting at negative infinity. And so we're going to do a parenthesis with negative infinity, and then the highest range value there is at what? And again, it goes back to your key points. We're going to use 0 with the domain, and we're going to use 4 with the range. 4 is that highest value of the range. Okay, so now y-intercept. Now we know we can plug in 0 for x and solve for y, or if you notice, we already have a point there on our y-axis. And so we actually already have our y-intercept, and that is 0, 4. But if you didn't see it and you plugged it in, you would get the same answer. Next question, the open interval where g is decreasing. And so again, starting from left to right, if you read this, do you see how it's going down the whole time? So the whole entire graph is decreasing. And so that is my domain, which is 0 to infinity. And that is where my graph is decreasing. Okay, we have another average rate of change problem. So again, this is giving me an x value and another x value, and I need to find the y value in order to find our average rate of change. Remember, in order to find your average rate of change, that's your slope, and the formula is y2 minus y1 over x2 minus x1. And so right now I just don't have enough information. And so one of my ordered pairs, the x will be 0, and we need to find the y. And then the other ordered pair, the x is 16, and we need to find the y. Now, again, I don't know if you noticed this, but we've already found when we plug in 0 for x. When you plug in 0 for x, you end up getting 4 for y. And I'm going to go ahead and just go through this problem with you now for this one. But you would go y equals negative 1/2 root 0 plus 4. Well, root 0, the square root of 0 is 0, and negative 1/2 times 0 is 0, and 0 plus 4 does give you the value for y equals 4. So there's one order pair. The second one, we're going to plug in 16 here into our equation. So we have y equals negative 1/2 root 16 plus 4. So 16 breaks down to 4 and 4, so pair of 4s. We have negative 1/2 times 4 plus 4. Negative 1/2 times 4 is negative 4 over 2. And negative 4 divided by 2 is negative 2. And negative 2 plus 4 gives you a positive 2. So we have our two ordered pairs now, 0, 4 and 16, 2. And we will just plug those into our equation for x and y in order to find our average rate of change, which is our slope. So starting here, I would go for my y's, 2 minus 4. Since I started here with the y's, I also start here at the x's, and so I have 16 minus 0. And so 2 minus 4 is negative 2. 16 minus 0 is 16, and then we reduce that and we get negative 1/8 for our average rate of change. And so it's saying that from 0 to 16, it's changing negative 1/8. That's the rate of change on the curve. Okay, last problem here. We have our h of x equation. Again, we'll notice that we have a dilation for the 2. Okay, so it's just going to shrink it or enlarge it based on that number. Okay, our starting point or our key point, we're going to go ahead and find that. And so for this problem, again, we set the x part equal to 0. And so the x value is going to be negative 4. And the y value is the value at the end, which is negative 1. So on the graph, we're going to go negative 1, 2, 3, 4, negative 1. And there is our starting point, our key point. So again, for domain and range, you could always wait and come back to this after you kind of put more points on your graph. But we do know with the domain, there's no reflections or anything, and so we don't have to, it's just gonna, we know it's gonna end up curving up and over here. And so our domain will always start there at that value. And so it's starting at negative 4 and it'll go to positive infinity. And again, with our range, we know it's going to go up and over. And so it's going to start for our range at negative 1 and go to positive infinity. Now for our x-intercept, again, we plug in 0 for y and solve for x. This is the same thing as having a y there. So we have y equals 2 root, and we're going, 0 equals 2 root x plus 4 minus 1. Okay, we want to get the root by itself, and so I'm going to add 1 to both sides. That eliminates. I have 1 equals 2 root x plus 4. You have a couple options at this point, but I'm going to go ahead and just try to get the root by itself. So I'm going to divide by 2. I now have 1/2 equals the square root of x plus 4. In order to get rid of that root, I need to square both sides. When you square a half, you square the top and the bottom. So 1 squared still gives me 1, 2 squared is 4, equals, and then now I have x plus 4. For some of you, fractions just scare you, so at this point, if you want to go ahead and eliminate the fractions by multiplying the entire equation by 4, you could. So if I do that, I'd multiply 4 to every single term. These eliminate. I have 1 equals 4x plus 16. To solve for x now, I would subtract 16 to both sides. That eliminates. We have negative 15 equals 4x. I divide by 4 to both sides. So x equals negative 15 over 4, but I would probably go ahead and divide that in my calculator to get an approximate, or actually an exact, negative 3.75. So my x-intercept is negative 3.75, comma 0. So we're going to go and plot that. So negative 1, 2, 3.75, the x-intercept is about there. Okay, your y-intercept, I don't have anything on my y-axis right now, so we're going to go ahead and solve for our y-intercept. That one we plug in 0 for x and solve for y. And so I would write y equals 2 root and then 0 for x. So we have 0 plus 4 under the root and then minus 1. So simplifying here, 0 plus 4 gives me the square root of 4. We just have minus 1. The square root of 4 breaks down to 2 and 2, so you have a pair of 2's. So the pair of 2's comes out with a 2, and we get 2 times 2, which is 4, and then 4 minus 1 equals 3. So my y-intercept is 0, 3. So 0 on the x, up 1, 2, 3 on the y, and so my curve looks like that. And you can double check with your domain and range, but it starts at -4, goes to positive infinity. Here it starts at -1, it's still going to positive infinity. Okay, the open interval where h is decreasing. So if you go left to right, do you see this is always increasing? So the open interval where it's decreasing would be none. Okay, and then it says the open interval where h is positive. Okay, and so it's positive, anything above the x-axis is positive. So starting at the x-intercept, it's positive, it's above. And so that interval, the x-intercept was at the -3.75, and so it's positive at -3.75 to infinity.